Hello students, welcome to the sixth lecture on the lecture series on decimals and fractions. Okay, we have previously done some previous year questions. Okay, so in this lecture we will also continue the same. Okay, so let's jump into the problems. Okay, we'll be covering previously year questions. Okay, so the problem is 0.125 plus 0.027 whole by 0.25 minus 0.15 plus 0.09. Okay, so here the problem is just a little bit clever. Okay, so the trick here is we'll use the formula a cube plus b cube is equal to a plus b into a square minus ab plus b square. Okay, you won't believe me unless I prove this to you, right? So let's prove it. So this will be a cube and minus a square b plus ab square, and then when we multiply b with this term, what we are left with is ba square. Okay, so these two will be vanished, and then it will be equal to minus ab square. Okay, so these two will be vanished, so plus b cube. Okay, so this is actually equal to a cube plus b cube. Okay, so this formula is correct. The formula is a cube plus b cube, a plus b multiplied by a square minus ab plus b square. Okay, so here you can see that 0.125 is nothing but 0.5 whole cube, right? 0.5 whole square is equal to 0.25 and multiply this with 0.5. Okay. So what we are left with is 125. So 0.125 is the answer. So here you can see that this is a cube, this is b cube. Okay, if a is equal to 0.5 and if b is equal to 0.3. Okay, and here a square minus ab plus b square. Okay, so what we are given here is a cube plus b cube whole by a square minus ab plus b square. Okay, so we can write the numerator like this: a plus b into a square minus ab plus b square, right? And divide by a square minus ab plus b square. So what we are left with is a plus b. What here a is 0.5, what here b is 0.3. So this will be equal to 0.5 plus 0.3, that is actually equal to 0.8. So this will be the final answer. Okay, so the final answer is 0.8. So the square root of 0.09. Okay, so since 0.3 is whole square, so you can see that 0.3 whole square is equal to 0.09. So that is why square root of 0.09 is equal to 0.3 positive square. Okay, so let's jump into problem number 18. So problem number 18 asks us that 0.121212 in the form of p by q is equal to what? Okay, so 0.121212, what we can write this as 0.12 bar. And I have told you in the previous lecture, whenever we have a repeating pattern after the decimal point, how we can show this in fraction form. Okay, so how we can show this in fraction form is first just count the number of digits that fits the pattern, right? That the number of digits that are being repeated. Okay, so here 1 2, only 2 digits are being repeated. Okay, so what I will do is I'll write 12 by 99 and this will be approximately equal to this. Okay, so this is equal to this. So how we can write this again or further simplify this? since 99 is divisible by 3, okay, 9 plus 9 is equal to 18, and 3 into 6 is equal to 18. So 99 is divisible by 3. Divisible by 3. And we all know 12 is divisible by 3. By 3. Okay, so 12 by 99 will be equal to 4 by what? 33. Okay, so 4 by 33 will be the final answer. Okay, let's jump into problem number 19. So it tells us that by what least number should 675 be multiplied so as to obtain a perfect cube number. Okay, so it tells us that 675 into x, okay, this is integer, is equal to y cube. Okay, and y is also an integer. Okay, what is the minimum x so that this will be become a cube. Okay, so let's see. So what we do here is we prime factorize 675. So how we'll do is since there is a 5 in the unit position, so we can say that 5 is divisible by 675 is divisible by 5. Okay, so by prime factorization what we found out was 5 into 5, that is 25, into 3 into 3 into 3, that is 27. So 25 into 27 is equal to this. So 675 is equal to 5 whole square into 3's whole cube. Okay, so if we just multiply by 5 here, so we'll multiply 5 down here also. So what it will be becoming is 5 cube into 3 cube. So what it will be further appear is 15 cube. Okay, so now we can write 675 as 15 cube. Any other number we can also multiply with different numbers and get the same, but what we need to do at least is we at least need to multiply with 5. So the least number will be 5. Okay, so the number multiplied is 5, and this is the least. This is the least number. Okay, so what problem number 20 tells us? So problem number 20 tells us that we have to add 4 mixed numbers. Okay, this is not a hard work, so let's convert these to fractions first. So 2 into 1 plus 1 is equal to what? 3 by 2, plus 2 into 11 plus 1, so 22 plus 1, 23 by 2. So 2 into 1, 1, 1 plus 1, so this will be equal to 2 to 2 plus 1, so 2 to 3 by 2. So this will be equal to 2 to 2 3 by 2. Okay, so since the denominators are same, so we can write the common denominator here and add the upper numbers there. Okay, so what we are left with is 1 2 3 4 plus 2, that is actually equal to 1 2 3 6. This is the final answer. Okay, problem number 21. Okay, so it asks us what 0.001 is equal to. Okay, so what we can do is we have 0.001. So what we do is multiply by 1000 and divide by 100. Okay, so if we multiply this by 100, that is 1000. So what we are left with is 1, and there is a 1000 in the denominator part, so this will be equal to this. So this is the final answer. Okay, so final answer. Okay, 0.001 is actually equal to 1 by 1000. So problem number 22. Okay, what we have is 0.1 into 0.01 into 0.001 into 10 power 7. Okay, so we already knew from the last question that 0.001 is actually equal to 1 by 1000. Okay, 0.01 is actually equal to 1 by 100. Okay, so 0.1 is actually equal to 1 by 10. Okay, So let's multiply this. So 1 by 1000 into 1 by 100 into 1 by 10 into 10 power 7. Okay, so what we can see here is 10 power 7 by 10 power 3 5 6. Okay, 10 power 6 here. So what we are left with is 10. Okay, so the final answer will be 10. Final answer 10. Okay, so let's see. So yes, 10 power minus 6 is there, because 1 by 10 power 6 is nothing but 10 power minus 6. Okay, so 10 power minus 6 multiplied by 10 power 7 is equal to 10. So 1.27 in the form of PYQ. Okay, what is it equal to? So 1.27 is equal to 127 by 100. Okay, so the value of 2 whole 1 by third minus 1 whole 2 by 11th whole by 3 plus 1 by 3 plus 1 by 3 plus 1 by 3. So this is not a hard one. What we need to do is we need to evaluate this or simplify this systematically. Okay, so what we need to do here is we need to simplify this first. Okay, then simplify this part first, then need to simplify this. Okay, this will be the process here. So first what we need to do was we need to simplify this. Okay, first this. So this was simplified and what we got was 9 plus 1 by 3. Okay, so since 1 by this is divided here, so what we can do is we can take the reciprocal here. So then what we took was its reciprocal. Okay, this is 10 and 3 got up here. Okay, so this become 3 plus 3 by 10. Okay, then we need to further simplify this thing. Okay, then after further simplifying, okay, just note down here, we also converted the mixed number into fractions. Okay, this is also very important. Meanwhile we simplify this, we will also simplify this. So simplifying this, what we are left with is, so this should be for 39, so 38 by 33 in the numerator, 38 by 33. Okay, so in the denominator what we are left with is 3 plus 1 by 30 plus 3 whole by 10. So again we take the reciprocal here and 10 by 33. So what we are left with is 38 by 33 whole divided by 99 plus 10 whole by 33. Okay, so this is equal to 38 by 33 into 33 by 109. Since 33 are there in the numerator and denominator, we can cancel each out, and what we are left with is 38 by 109. So 38 by 109 is the final answer. Okay, so problem number 25, it asks us that find a number 1/7 of which exceeds its 11th part by 100. Okay, so the question is 1/7 of which exceeds its 11th part by 100. Okay, so let the number be x. So basically what it told us was it's 1/7 exceeds what 11th part by 100. Okay, so the difference of x by 11 must be 100. So x by 7 minus x by 11 is equal to 100. Okay, we need to solve this. So how we will solve this? So 77 and 11x minus 7x is equal to 100. So this implies that 4x is equal to 7700. So this implies that x is equal to 7700 by 4 is equal to 1925. So this is the final answer. Okay, so what problem number 26 asks us is 3 minus 3 plus root 5 by 4 minus 1 by 3 plus root 5. Okay, what is it equal to? Okay, so let's explore this. So 1 by 3 plus root 5 is equal to 3 minus root 5. Okay, so 3 minus root 5 by 3 plus root 5 into 3 minus root 5. What we do is we try to remove the square root part in the denominator. Okay, how we can do this? We have already discussed. What we do is we multiply it with its square root conjugate. Okay, so if a plus square root b is there, what we multiply it with is a minus square root of b. So what will be left with is a square minus b. Okay. So this is 9 minus 5. So this is equal to 4. So 3 minus root 5 by 4 is the answer here. Okay. So 3, what we are left with was 3 minus root 5 by 4. Okay. So now what we have done is we have converted this to this one. Okay. And see here that we have the denominator same. Okay. So here we are. Okay. So 3. Okay. Let's solve this. 3 minus 3. This will also be a minus square root of 5. Okay. This one to be free. This will be 12. Okay. Then since we have a negative down here, so minus 3 plus root 5. Okay. Root 5 cancels each out. And 4 is here. And 12 minus 6, that is equal to 6 by 4. So 3 by 2 in simplified form. This is the final answer. Okay. So the value of 1 plus 1 by 1 plus 2 by 3 plus 4 by 5. Okay. As we have previously seen, what we need to simplify first? 3 plus 4 by 5. So this will be equal to what? 5 into 3 is equal to 15 plus 4 by 5. This is equal to 19 by 5. Okay. So this thing is simplified now. So 1 plus 1 by 1 plus 2 by 19 by 5. Okay. So this is equal to 1 plus 1 by 1 plus, okay, 5 into 2 is equal to 10 by 19. Okay. This will be equal to 1 plus 1 by 19 plus 10 whole by 19. Okay. So this is nothing but 1 plus 19 by 29. Okay. So 29 plus 19 by 29. So this is equal to 30, 48, 29. 48 by 29 is the final answer. Okay. So what he did first was they simplified this term. Okay. Then they got to this term. They simplified this and they are left with this part down here. Okay. So the process is very important. How you proceed to the problem. First you try to simplify this term. Then you try to simplify this one. Then you try to simplify this. And then it is easy to get from here to here. Okay. It is a really easy path. So a rational number between 3 by 4 and 3 by 8 is which of the following number is a rational number and it lies between 3 by 4 and 3 by 8. The question is this. So the numbers given down to us is 16 by 9, 9 by 16, 12 by 7, 7 by 3. Okay. So let's see. So 3 by 4 is equal to what? 12 by 16. So 3 by 8 is equal to 6 by 16. 6 by 16, 7 by 16, 8 by 16, 9 by 16, 10 by 16, 11 by 16, 12 by 16. So the required rational number will be 9 by 16. Okay. So let's jump to problem number 29. If x is equal to 1 by square root of 2 plus 1. Okay. Then x plus 1 is what? So x plus 1 is nothing but 1 plus x, that is equal to 1 by root 2 plus 1 plus 1. So this is equal to root 2 plus 1 plus 1 whole by root 2 plus 1. So this is equal to root 2 plus 2 by root 2 plus 1. So if we further simplify to get the denominator square free, what we need to do is we multiply with root 2 minus 1. So this will be become 2 minus 1 and in the whole numerator root 2 plus 2 into root 2 minus 1. Okay. So this will be equal to 2 minus root 2 plus 2 root 2 minus 2 whole by 2 minus 1, that is equal to, so 2 minus 2 cancels each out, so root 2 by 1 is equal to root 2 is the final answer. Okay, so let's see. Here you can see that if x is equal to this, then x plus 1 is nothing but equal to this one here. Okay, they made the denominator square free as we did. Okay, and what we got was root 2. So let's solve problem number 30. So if 3 by 4 of a number is 7, more than 1 by 6 of the number, exactly that number, okay, then 5 by 3 of that number is. So let the number be x. So 3 by 4th of that number is actually 7 plus 1 by 6th of that number. Okay. So let's solve this. So solving this. So 3 by 4 x minus 1 by 6 x is equal to 7. Okay. So for 4, 6, 12 will be the LCM. Okay. So since we made the denominator 12, we need to change the numerators. So 4 into 3 into 3, 9x minus 6 into 2. So 2x is equal to 7. So 7x by 12 is equal to 7. Okay. So this implies that x by 12 is equal to 1. So this implies that x is equal to 12. Okay. So x is equal to 12 will be the answer. Okay, they did the same right here. Okay, you can see, and then this. Okay, 9x minus 2x is equal to 7x. So what we did here was x by 12 is equal to 7 by 7. This implies that x is equal to 12. Okay, this was the final answer. So let's revise the problems that we did today. Okay, so in problem number 16, we use this formula. Okay, this is the very important formula, and this will be widely used. Okay, in this topic. So you saw here. Okay, then we found out the square root of 0.09. That was very easy. Okay, 0.3. Okay, then we tried to convert this to a fraction form. Okay, and we got the trick, that is divided by the number of terms that are being, the number of digits that are being repeated with the number of digits with 9. Okay, so then the next question, what we did was we converted this to a perfect cube. What we need to multiply with 675 to make it a perfect cube, and the minimum number, that's what we needed. Okay, so then we added mixed numbers and it was easy, and then we tried to convert some decimal numbers to fractions. Okay, then we multiplied this each number with some whole numbers with decimals. Okay, and we again converted this number to fractional form. Okay, and then in 24 what we did was, okay, here you need to note down that the process, you need to simplify this first, then this first, this part, and then this part. Okay, something like this, and then we solve these tricky ones. Okay, the trick here is consider the number as x and then just convert it to the equation for the given word problem. Okay, so the equation was something like this here, and again we also solved this. Okay, converted the denominator to whole numbers. Okay, that was 4 here, and then solved it. We got 3 by 2, and again that same process here. Okay, and then we also did this one here. Okay, and we found out this was the final answer. Okay, and okay, similar problems, and at the end what we did was this one. Okay, thank you.